In the last set, we looked at solving equations, but we solved, equations, theta, so some part of this is going to be the same, 0 between 2 pi. But then the issue was we looked at really nice equations before. We had things like cosine of theta equals, and then over here we had numbers which were very familiar, numbers that showed up as part of the x-coordinate, in this case for cosine anyway, but as part of the x-coordinate or the y-coordinate for sine of theta on the unit circle. But what if you don't have that kind of number, right? So what if you have a 0.8? If you had a 0.5, then great, this would be so nice. But because there's a 0.8, well, there's a point on the unit circle where the x-coordinate is 0.8, but it's not as easily accessed or recognized, and this is where we're going to need to start to use some inverse functions. So let's draw a picture. And what happens here is, well, where is the x-coordinate going to be? 0.8. Well, here's where x is 0.5. 0.8 is probably somewhere like over here. And so we're looking at a point right there, and then one down here. Those are the 2 points which correspond to 2 different angles if we were to draw on the angles. Of course, drawing the angle, so the circle is bad, right? Because this angle here should really be the same size as this angle there. So sorry about how poorly this is drawn, but one solution looks like this, which is between 0 and 2 pi, and then the other, it has to be between 0 and 2 pi, has to be a counterclockwise angle like that. Well, one of the things that we had mentioned in class was that well, here you can swap these two, and so you have theta is equal to cosine inverse of 0.8, and if you want to maybe write that a little bit more cleanly, you might write theta is equal to cosine inverse of 0.8. And though we'll learn some of this a little bit later, the inverse cosine of a positive number is always an angle that's in the first quadrant. And so what angle is that? That's got to be this angle right here. Okay, this angle right there is this angle that's in the first quadrant. And cosine of that angle should give us a 0.8. So this angle right here exactly is cosine inverse of 0.8. And if you go to a calculator, you don't need this number, but go to a calculator, or I just typed into Google, I typed in arc cos 0.8, and this told me, Google said that this was 0.64 radians, and you don't need the number specifically, but it's just nice to know that this inverse cosine of 0.8 really just is a number. So if we have that, that's already one of our 2 solutions. The other solution, take a look, it really comes from the picture. Let me do some highlighting in a different color. But there's this reference angle, and sorry for how poorly the circle is drawn, but that other red arc is supposed to be the same size angle. And if that's the case, that means this second angle here, this one, if I highlight this in blue, well, that's really, the angle here. I'd like to label this here, but it will get a little bit messier with what we're going to do next. But that angle really has to be, so I'll label the point, which is not the angle itself, but this has to be 2 pi minus cosine inverse of 0.8. Now, I think it is most natural to solve this question the way we did by using the unit circle, but I would just like to point out that there's so many connections. It's worth understanding what's going on just in terms of the graph. So let me sort of do that a little bit tinier and over here. So sorry that the pictures are mixing a little bit, but there's your standard graph of cosine. That top bump is the start of a new period, so that's 2 pi. Halfway in between right here, that's got to be pi, and halfway between the upper bump and the lower bump, this actually, sorry for the bad picture, should be halfway in between these two, and that's pi over 2. So then what we're really doing is looking at this line 0.8. Let me try to draw that. Okay, that's the output of cosine, and so we're looking for an angle right here, and we're looking for whatever this angle is right there as well. Well, this angle right there is the cute one. This is the one that's occurring before this pi over 2. And so this is that cosine inverse of 0.8. And then finally, take a look inside this picture. This distance right here, if you were to just flip the graph of cosine, this is not a usual place to flip, but if you flipped along this line as a mirror, we just flipped along that line, well then, this piece would match up with that piece and so on, and so then this length right here, which corresponds to this one, would actually match up with that one right there. And so you can actually see from the picture, if we're trying to find this, the corresponding angle to the one in blue, if we're trying to find this one, well, you travel this entire 2 pi distance, but that's too far, so you go backwards a little bit. You go back by, well, this cosine inverse right there. So you can see from this graph picture as well that you have 2 pi minus cosine inverse of 0.8.